Hi amigos, welcome back to my YouTube channel Mathsphobia. In the earlier video, we have discussed exercise 6a first Roman. So now let's discuss the second Roman of exercise 6c. The first sum, it is given that cos alpha is equals to minus 3 by 5 and sin beta is equals to 7 by 25, where pi by 2 less than alpha less than pi and 0 less than beta less than pi by 2. Then find the values of tan of alpha plus beta and sin of alpha plus beta. In order to solve this sum, we have to find the values of tan of alpha plus beta and sin of alpha plus beta. Solution. We have to find tan of alpha plus beta, which means tan alpha plus tan beta by 1 minus tan alpha tan beta. And the value of sin alpha plus beta is sin alpha cos beta plus cos alpha into sin beta. So in order to find the values of this, we have to find the values of tan alpha, tan beta, sin alpha cos beta, cos alpha sin beta. First take the given one. Cos alpha is equals to minus 3 by 5. Simultaneously take sin beta is equals to 7 by 25. According to all silver teacups, 0, 90, 180, 270, 270 and 360. It is given that alpha greater than 90. So alpha is greater than 90, which means here, and less than 180. So from this given information, we know that alpha lies in quadrant 2. Similarly, 0, 90, 180, 270 and 360. 0 less than beta and less than pi by 2. B is greater than 0. B is greater than 0 and less than pi by 2. So beta lies in quadrant 1. In quadrant 1, all the trigonometric ratios sine, cos, tan, cosecant, secant and cot are positive. In quadrant 2, sine and cosecant are positive. Rest all trigonometric ratios are negative. So from this, find the value of sine alpha. Sine alpha by Pythagoras theorem, we get 4 by 5. As it lies in second quadrant, sine is positive. So it is plus 4 by 5. Find the value of cos beta. According to the Pythagoras theorem, we get it as 24 by 25. As quadrant 1, cos is positive, it is plus 24 by 25. So even you have to find the value of tan alpha and tan beta. Tan alpha is equals to sin alpha by cos alpha, which means 4 by 3. As tan is negative, in quadrant 2 it is minus 4 by 3. Tan beta is equals to sin beta by cos beta, which means 7 by 24. Substitute the values in this above formula. Tan alpha plus tan beta by 1 minus tan alpha tan beta, minus 4 by 3 plus 7 by 24 by 1 minus of 4 by 3 into 7 by 24. LCM is 8. So minus 4 into 8 plus 7 by 24 by 1 plus 4 by 3 into 7 by 24. 1 zar and 6 zar. 8 4s are 32 plus 7 by 24 by 18. Here LCM is 18. 18 plus 7 by 18. This is minus 25 by 24 and 25 by 18. Cancel. Minus 18 by 24. 9 by 12. 3 table. 3 by 4. So the value of tan of alpha plus beta is minus 3 by 4. Similarly, find the value of sine of alpha plus beta, which means sine alpha cos beta plus cos alpha sine beta. The value of sine alpha is 4 by 5 and cos beta is 24 by 25. Cos alpha is minus 3 by 5 and sine beta is 7 by 25. 24 fours are is 96 and 7 threes are is 21 by 125. 75 by 125. Cancel with 25 table. 25 threes are and 25 fives are, which means 3 by 5. So the value of sine of alpha plus beta is 3 by 5 and the value of tan of alpha plus beta is minus 3 by 4. I hope you have understood the previous solution. So let's go to the next question. 0, a greater than 0 and b less than pi by 4, and sine of a plus b is 24 by 25 and cos of a minus b is 4 by 5. Find the value of tan 2a. So 0, 90, 180, 270 and 360. A is greater than 0. So A lies in first quadrant. B is less than pi by 4. If we consider this as 45, it is less than pi by 4. So both A and B lies in first quadrant. A and B lies in first quadrant. So the given condition is sine of a plus b is equals to 24 by 25 and cos of a minus b is 4 by 5. From this, find the value of tan of a plus b, which is 24 by 7, and similarly find the value of tan of a minus b, which is 3 by 4, by using Pythagoras theorem. So here he asks us to find the value of tan 2a. Tan 2a is equals to tan of a plus b plus a minus b. So if a gets cancelled, it is tan 2a. So consider this as 1 and this as 1. Tan of a plus b, which is tan a plus tan b, 1 minus tan a into tan b. So substitute the values. Tan of a plus b is 24 by 7 plus tan of a minus b is 3 by 4 by 1 minus 24 by 7 into 3 by 4. Here LCM is 28. So 24 into 4 plus 3 into 7 by 7 into 4, and here LCM is 28 again. 28 minus 24 into 3 into 28. 28 and 28 gets cancelled. 24 into 4 plus 21 by 28 minus 72. 96 plus 21 by 28 minus 72. 96 minus 21 is 75, and 28 plus 72 is 100. So this is 3 by 4. Coming to the next question, it is given that tan alpha minus tan beta is m, and cot alpha minus cot beta is equals to n. Then find the value of cot of alpha minus beta is 1 minus m by minus 1 by n. So we have to prove that cot of alpha minus beta is 1 by m minus 1 by n. So expand this. Cot alpha into cot beta minus cot beta minus cot alpha. So we have to find the value of this in order to prove this. So take this, take equation 1 and equation 2. From equation 1, it is given that tan alpha minus tan beta is equals to m. Tan alpha can be written as 1 by cot alpha minus tan beta can be written as 1 by cot beta is equals to m. Cot beta minus cot alpha by cot alpha cot beta is equals to m. And from equation 2, that is cot alpha minus cot beta is equals to n. Take minus common, so minus of cot alpha plus cot beta is equals to n. Take this minus to RHS. Minus of cot alpha plus cot beta is equals to minus n. As we have got the value of cot beta minus cot alpha as minus n, substitute in this. Minus n by cot alpha cot beta is equals to m. So reciprocal the terms. Cot alpha into cot beta is equals to 1 by m. Cross multiply. Cot alpha into cot beta is equals to minus n by m. So finally we have got the value of cot alpha into cot beta as minus n by m, and cot beta minus cot alpha is minus n. Substitute the values. Cot of alpha minus beta is minus n by m minus 1 by minus n. LCM is m. Minus m by m into n. So the cot of alpha minus beta is cot alpha cot beta plus 1 by cot beta minus cot alpha. So this is the value, m minus n by minus of m into n. So take individually. N by minus m into n. M gets cancelled and n gets cancelled. Minus and minus gets cancelled. From this you will get plus 1 by m minus 1 by n. Thus proved. I hope you have understood the previous sum. So let's go to the next sum, which is given that sine of a. We have to find the value of sine of a plus b minus c. So the value of a plus b, consider a plus b as one term, small a, and minus c as c. This is in the form of sine of a minus b, which means sine a cos b minus cos a sin b. Here a is a plus b. Here b is c. Cos c minus cos of a plus b into sin c. Again you have to expand this sine of a plus b into sin a cos b plus cos a sin b into cos c minus cos of a plus b is cos a cos b minus sin a sin b into sin c. Multiply cos c in cos c inside, sin a cos b cos c plus cos a sin b cos c minus multiply sin c inside, cos a cos b sin c plus minus of minus plus sin a sin b and sin c. So this is the value of sine of a plus b minus c. I hope you have understood the previous expansion. So let's go to the next bit of second one. It is given that in a triangle ABC, A is an obtuse angle if sin A is 3 by 5 and sin B is 5 by 3, then show that sin C is 16 by 65. So from the above first line of the question, it is given that ABC is a triangle. So if ABC is a triangle, A plus B plus C is 180 degrees. Take this C to RHS. A plus B is 180 degrees minus C. As we want the value of sin C, apply both side by sin. Sin of A plus B is equals to sin of 180 degrees minus C. 180 degrees minus C. This is in the formula of sin of A plus B, which is sin A cos B plus cos A sin B. And sin of 180 minus theta is sin theta. So the value of sin A is 3 by 5. And cos B, we have to find the value. And the value of cos A and sin B is 5 by 3. So take an right angle triangle ABC with angle at C A 3 by 5. So by Pythagoras theorem, the adjacent side is 4. From this you get the value of cos A to be 4 by 5. Similarly, angle B, this is 5 and 13. By Pythagoras theorem, you will get our adjacent side is 12. So cos B is 12 by 13. Substitute the values. The value of cos A is minus 4 by 3. So this is 36 by 65 minus 20 by 65. So it is 16 by 65. So finally we got the value of sin C to be 16 by 65. In the next question, it is given that sin of alpha plus beta by sin of alpha minus beta is equals to a plus b by a minus b, and ask us to prove that a tan beta is equals to b tan alpha. So expand this formula. This is in the compound angles formula, sin alpha cos beta plus cos alpha sin beta. Similarly, sin alpha cos beta minus cos alpha sin beta, a plus b by a minus b. Rationalize RHS. So take this sin alpha cos beta plus cos alpha sin beta down, same. cos beta minus cos alpha sin beta. A plus b. We are going to solve this problem by using componendo and dividendo. Which means add denominator by subtract denominator is equals to a plus b plus a minus b by a plus b plus b minus a. From the compound angles formula, we have learned that sine of alpha plus beta plus sine of alpha minus beta is 2 sine alpha cos beta. Similarly, sine of alpha plus beta minus sine of alpha minus beta is 2 cos alpha sin beta is equals to b and b get cancelled and a and a get cancelled. 2a by 2b, 2 to cancel. So this is sin alpha by cos alpha is tan alpha, cos beta by sin beta is cot beta is equals to a by b. Cot beta can be written as 1 by tan beta is equals to a by b. Cross multiply this. B tan alpha is equals to a tan beta. So we have proved that the value of from this to this. Going to the next sum. Next Roman, it is given that a minus b is 3 pi by 4. Then show that the value of 1 minus tan a into 1 plus tan b is 2. We have solved the similar sum in examples. So in the same procedure we have to solve this sum. Take a minus b is 3 pi by 4. Apply both sides by tan. Tan of a minus b is equals to tan of 3 pi by 4. Expand this tan a minus tan b by 1 plus tan a into tan b. 3 into 180 by 4, 180, 45, and this is tan 135 degrees. Tan 135 can be written as tan of 180 minus 45. Sorry, 90 plus 45. Tan A minus tan B by 1 plus tan A into tan B, which is tan 90 plus theta is cot theta. As 90 plus theta lies in first quadrant, second quadrant tan is negative in second quadrant. This is minus 1 minus cot 45. So the value of minus cot 45 is minus 1. Cross multiply. Tan A minus tan B is equals to minus 1 minus tan A into tan B. Tan A minus tan B. Take this minus tan A into tan B to LHS. Into tan B is equals to minus 1. Now take the given condition that tan B. Multiply using distributive property. 1 plus tan B minus tan A minus tan A tan B minus tan A tan B. The value of tan B minus tan A minus of tan A tan B is 1 from equation 1. So this is proved. So we have proved that 1 minus tan A into 1 plus tan B is equals to 2. In the next question, it is given that a plus b plus c is pi by 2, and if none of a, b, c is odd multiple of pi by 2, then prove that cot a plus cot b plus cot c is equals to cot a, cot b, cot c. So take the given condition a plus b plus c is pi by 2. So take this c to RHS. A plus b is equals to pi by 2 minus c. As we have to prove this, multiply both side, apply both side cot. So cot of a plus b is equals to cot of 90 minus c. This is cot a cot b minus c by cot a plus cot b. Cot of 90 minus theta is tan theta. Cot a cot b minus 1 by cot a plus cot b. Tan c can be written as 1 by cot c. Cross multiply. Cot a cot b minus 1 into cot c is equals to cot a plus cot b. Multiply this cot c into the brackets. Cot a cot b cot c minus cot c is equals to cot a plus cot b. Take this minus cot c to that side. Cot a into cot b into cot c is equals to cot a plus cot b plus cot c. Thus proved. I hope you have understood the problems explained today. Stay tuned for the next series of videos.